Alright, so in this video we're going to investigate the difference quotient, what it means, and most importantly how to compute it, because this is going to be a key idea when you get to calculus. We're going to need to compute these and understand these. So, background. So here is a curve. I'm just going to draw a generic curve in the xy plane here. And let's say that we're concerned with the rate of change of the function, the average rate of change of the function between these 2 points. Well, the average rate of change is just a slope between the 2 points. So I'm going to say that this coordinate right here has x value x, or x coordinate x. And I'm going to say that this one is at x plus h. Okay, so that means that these 2 points are h units apart. Okay, so the actual coordinates of these points are x comma f of x and x plus h comma f of x plus h. So the difference quotient is the slope of the line between those 2 points, which is just basically difference in the y's over difference in the x's. So I'm going to use the x plus h as the first point I put in there. So f of x plus h, and that means downstairs it's x plus h, minus the y coordinate of the first point over the x coordinate of the first point. And this does simplify quite a bit. You know, I can't do anything with the numerator because I don't know what f is, but the denominator has x plus h minus x, and I'll even put this in parentheses if that helps a little bit there. And this right here is your expression for the difference quotient. So there's really no need to go back to the picture anymore, but this is what it means for all of these different functions. So it's basically pick any 2 random points and find the average rate of change where you just call one x and one x plus h. So we're just going to look at a couple examples. So if f of x equals 3x plus 2, now I am going to use the picture for this one just to prove a point. So that is going to look something like this. It's a line that has slope 3 and y-intercept 2. So whatever I pick for x and x plus h, you notice that the slope between those 2 points is the slope of the line. So the difference quotient should be 3. Now let's just see what that looks like as we do this algebraically. So I'm going to write the expression down. And what I do, I look at this piece by piece. So the first thing I am going to focus on is f of x plus h. And that is 3 times, now remember, f of the input is 3 times the input plus 2, right? So that means it's 3 times x plus h plus 2, which, you know, nothing very exciting here, but we have that. Now, I'm going to now worry about the numerator. Since I already know what f of x is, I can now jump to this. So f of x plus h is 3x plus 3h plus 2. And I'm subtracting 3x plus 2. That was the given f of x. And I have to put it in parentheses because it has more than one term. I have to make sure I subtract the whole thing. So this is 3x plus 3h plus 2 minus 3x minus 2. And 3x is crossed out, 2 is crossed out, and this is 3h. So that means that the difference quotient is equal to, well now, this is, I'm just going to highlight this here, this is the numerator of the difference quotient. So that means my difference quotient becomes 3h over h, which is 3. And that should not be a surprise again, because again, the difference quotient tells you basically an expression for the slope between any 2 points. Okay, so now let's make this a little bit more complicated, because now we're talking about a parabola. That doesn't always have the same slope. So again, I'm going to find f of x plus h, and that's going to be x plus h squared plus 4. And I am going to take the time to do the algebra. Now remember, this is really FOIL, right? So this is x plus h times x plus h. And then that's what we end up with there. There's really nothing more to do there. So I'm now going to jump right to f of x plus h minus f of x. And that is, well, I'm going to write it down here. X squared plus 2hx plus h squared plus 4 minus, now f of x was x squared plus 4. So again, I have to make sure that I put that in parentheses. And then combining like terms, well, x squared plus 2hx plus h squared plus 4 minus x squared minus 4. Those are going to go away. Those are going to go away. 2hx plus h squared. And again, this quantity right here is the numerator of the difference quotient. So that means that the difference quotient is 2hx plus h squared all over h, right? Now, to simplify that, there's a couple ways you could do it. You could factor in h out of the numerator. I prefer to split it up, just because that's something we're more familiar with. And there is the expression for the difference quotient. So it depends on what x and h are, and that's usually what happens with difference quotients. All right, so that's how you do that for a quadratic. Basically the same procedure for almost anything. It's just a matter of remembering how do we simplify different things. And now we're going to talk about a fraction. So just as a reminder, I'll write the difference quotient again, the expression for it. So f of x plus h is 3 over x plus h, and there's really nothing to do with that. So that means that the numerator is 3 over x plus h minus 3. I meant to say f of x plus h minus f of x. Let me just fix that real quick. F of x plus h minus f of x. There we go. Now, there's two roads we can take here. I'm going to show you the complex fraction way. So I'm actually going to replace this into the numerator. So we're going to have 3 over x plus h minus 3 over x over h. So we have what's called a complex fraction because it's a fraction within a fraction. So I have to remedy that by looking at this expression right here. So I'm going to multiply. Notice that this is a big fraction. I'm going to multiply by a form of 1 that's going to wipe out the fractions. And that's our link to the least common denominator, lowest common denominator. And that is x times x plus h. Now, the way I'm handling that, I am not going to multiply the denominator out for a good reason. We want to make sure that whatever we get a simplified fraction, which means removing common factors. So I have to make sure that I'm set up to do that. So if I multiply this first term by this term, so this is going to get distributed to each term here. I'm going to have a 3x times x plus h over x plus h, which is just going to give me 3x. When I distribute this term to the 3 over x, the x's are going to cancel out, and I'm going to have 3 times x plus h. And my denominator, I'm just going to leave it in this form right here. There's a good reason again, okay? So now we work on simplifying the numerator. So we have 3x minus 3x minus 3h all over hx times x plus h. And remember, that's just part of your strategy of simplifying fractions, right? You always want to leave it in factored form if you can, multiply out and combine if you have to, if it's not in completely factored form. So that's kind of why we're doing what we're doing here. So 3x is crossed out, and we get negative 3h over hx times x plus h. And now would you look at that? The h's cancel out. So that is a common theme with computing difference quotient. We always want that h to go away. And this is your final answer. So hopefully that makes difference quotients a little bit easier for you. Gave you a couple examples there and what it means. So continue to practice this and you're going to master this. I just know it. Thanks so much for watching.